Launch escape system. This was actually another rocket. It was filled with solid rocket fuel, and there was a motor on the inside of it with 4 nozzles that were designed to fire up and pull the spacecraft away in case of an emergency. So at the first stage, so this was a super powerful rocket. It was actually more powerful than the Mercury Redstone. It didn't burn for as long, but it had almost double the amount of thrust. Yeah, so that's the rocket from head to toe. On the day of launch, the 5 F1 engines lift the entire stack off the pad at a force of about 7.5 million pounds of thrust. That's about 1.5 million pounds per engine, making the F1 engine the most powerful liquid-fueled single-chamber rocket engine of all time. And these things were gas guzzlers. Like, they would burn through more fuel in 1 second than Charles Lindbergh used in his entire flight across the Atlantic in 1927. In fact, it was over 10 times as much fuel burned in a single second than Lindbergh's entire flight. And they would only burn for like 2.5 minutes, and then it just takes 2.5 minutes to empty out this whole first stage. And now this entire rocket weighs less than a third of what it did when it was sitting on the pad just a few minutes ago. So crazy, right? 2.5 minutes, they're done with the first stage. We disconnect it, throw it away, and it crashes into the Atlantic Ocean, never to be seen again. Then the second stage fires up. Shortly after the second stage fires up, network error. I guess I can't use my visuals anymore. Oh no! Oh wait, here we go. This ring will actually fall away. You've probably seen this famous shot from Apollo 4, that ring kind of falling away towards Earth. So I can't actually remove it on the model here, so just imagine that kind of going. Right after that, the launch escape system is no longer needed, so that flies away. The second stage will continue firing for a total of about a little over 6 minutes. It has 5 Rocketdyne J2 engines on the bottom of it. Now these J2 engines were a lot more fuel efficient than the F1s, but they were a lot less powerful. In fact, if you add up all 5 of these working together, it was about the equivalent of one of these F1 engines. So that kind of just shows you how powerful this first stage had to be to get us from a standstill into almost space. Once we're done with the second stage, it's taken us almost into Earth's orbit. We separate it out. It crashes into the ocean, never to be seen again. And then our third stage fires up. It fires for about 2.5 minutes to take us into what's called a parking orbit around the Earth. During this parking orbit, we're going to check all of our systems, make sure we're ready to go to the moon, make sure we're aligned with our proper heading, and then at the right time, we're going to fire up this engine again, and it's going to send us on a trajectory towards the moon. It's going to burn for about a little under 6 minutes in what's called the translunar injection burn, or TLI for short. After TLI, we shut off the engine, and now it's time to get our lunar module out of here. You guys ready for this? All right, our spacecraft is going to